Setting up Prism is very simple, but takes a few steps, and let's just go through those now to show you exactly what has to be done. First of all, we want to set the location of the observing site. And what we do here is we have a selection of either geographical locations along the bottom here, observatories, or IAU sites. And let's choose IAU sites, and we'll go down to the bottom and then just come up a bit to pick the remote observatory that we're using in Chile. So we select that, shows the selected place. We can modify it if we want, and then we'll go ahead and select this as our default location. We get a confirmation that in fact this will be our default location. And that's all there is to it in terms of selecting the geographical location that we're using. Next we go to settings for hardware. And here's the opportunity to set up all the different hardware components that you have. First of all, we'll pick the telescope type that we're using. Normally we'd be choosing an actual telescope type, such as astrophysics or a Paramount from Software Bisque, one of those type of instruments, but in this case we'll choose the ASCOM simulator just to get something into the system to show you how it's organized. And of course you have the ability of setting all the specific parameters, and you'd follow the manufacturer's instructions when it came to that. In terms of the limits that we have on the system, we want to basically be able to get a warning when the elevation limit goes down below 15 degrees, and the critical elevation where we really don't want to go is 5 degrees or lower. We also can specify max and min declinations. One of the important things we have to remember is that the PC time must be set correctly for the geographical location, or else the mount can get very confused and potential damage can occur, so you want to double check that. In terms of the pointing model, we're not using one, but this is where you would enter the pointing model enable as well as the actual location of the correction files. We can specify an auto guiding device, or we can use the ASCOM pulse guide technique. Here we specify a focuser, and in this case we're using the ASCOM simulator, and this is connected to camera number 1, and we have the parameters associated with that. We're not using a second focuser. For our filter wheel, we've chosen to use an FLI filter wheel which has 5 filters. We've chosen the reference filter as number 1, and we've told it that we want to have the focuser go to 3.56 millimeters when the system is started up, so that we actually have the system pretty close to being in ideal focus. One thing to remember is that Prism uses millimeters of distance on the focuser rather than steps, and there's an easy conversion you can use to calculate the number of millimeters required. We're not using filter wheel number 2, and for the dome we put in a simulator dome using the ASCOM simulator. We do have a GPS available, and that's hooked up so we can get precision time as well as geographical location. This just confirms our place. It's read only. We can't change it in this location. We've already changed it previously. But what it does do is it specifies very clearly what universal time is versus the local hours, so we can verify that so we have accurate pointing. Not using a weather station in this particular case, but this is where you would set that up, or a cloud sensor where you could add a Boltwood cloud sensor or equivalent, and not using a field rotator here as well. There's also the capability of using switches, and this is where you enable switches that will be used in the observatory to control things like mount power, PC power, and so forth. And the cameras have a separate little setup area. Here we have a QSI camera that we've set up and we've selected. And we also have the ability of setting up the particular optics that we're using. So we're using a C14, and very important factor is the focal length. It's used by a lot of different features, and it's important to have the focal length entered there. And you can just specify the manufacturer's focal length. What you do, some plate solves, you'll find that you'll get a precision focal length for your particular system, and that's particularly true if you're using a focal reducer or a coma corrector. We specify the diameter, and we just get confirmation of that as well. We can also get this kind of data, as I mentioned, from a plate solved image. There's also set up for the particular factors on this particular camera, such as using the guiding point if we wish, and using the embedded filter wheel. So that camera is all set to go, the QSI on camera number 1. Camera number 2 and 3, I've simply selected simulation cameras, and that's just more of a default value at this point for this demonstration. So once you have all of that selected, we simply hit OK, and the system is ready to go. So setting up the system is fairly quick and easy, and actually engaging Prism with the hardware is also a simple process. It's a two-part process effectively, because the first thing we do is we enable the telescope, the filter wheel, all the other equipment except the cameras. So we click that icon, and then it goes through and starts to select all the different components and link them into the system. And we get a summary which gives us information that tells us the telescope we're using is the ASCOM simulator. We're going to actually use telescope pulse guide for the RA slow motion, no clouds or switches. We're using the simulator for the focuser. We're using the FLI filter wheel, ASCOM dome simulator, and that all looks right. So we'll click OK, and all of that is connected up and operational. And you can actually see the little flashing indicators at the bottom of some of these screens, which show that the system is active and alive. You'll also notice that our focuser has been shifted up to 3.56 millimeters, or 178 steps in the case of this simulated focuser, to match up with filter number 1. The filter control has been selected to filter number 1 just as we requested. So that's all good to go. Next thing to do, we establish the link to the camera, and camera number 1, our QSI, comes up, comes alive. And now we have the ability here of the first thing we normally would do is go to the temperature area, and we would select the set point for the temperature and the cooling power. And we've had this running for a little while, and it's sitting at about 0 degrees Celsius, and we can see how much cooling power is being used. So the camera is good to go. The focuser is set, the dome is good, the filter wheel, all our equipment is up and running. And the next step would be to actually open up a sky chart, where we start to actually pick our targets and start to go to the particular targets they want to go to. And we'll cover that in another video.